So let's look at this practice. So write the set of quantum numbers that describes each electron in the 3p orbitals. Alright, so to do this, let's write down the first quantum number. If we're calling the orbitals 2p, this 2 is referring to the n level. So all the orbitals are in the second energy level or shell, so they all have the n. Also, our L value is going to be equal to 1 because if we have a p subshell, that means that our L value is 1. Now, let's look at what our ML values are going to be. If L equals 1, our ML values are going to be -1, 0, and 1. So let's write this out. Here are the 3 quantum numbers for each orbital. N equals 2, L equals 1, ML equals -1. The second p orbital, N equals 2, L equals 1, ML equals 0. And the third p orbital, N equals 2, L equals 1, ML equals 1. Now, we want to remember that 2 electrons can fit in each orbital. So, since we're looking at each electron in these orbitals that can exist, each orbital, ML equals -1, ML equals 0, and M equals 1, each of these orbitals can accept 2 electrons. But one has to be spin up and one has to be spin down. So if we look in this first orbital, one electron can be spin up and the other one can be spin down. In the next orbital, one can be spin up and one can be spin down. And then in the third orbital, one can be spin up and one spin down. So for each electron in this orbital, they're going to have the same 3 quantum numbers, and then their spins will be different. For each electron in this orbital, they're going to have the same these 3 quantum numbers that are the same, and then opposite spins. And then each electron in this orbital is going to have the same 3 quantum numbers, and then their spin will be different.